exercise 1.1 of 9th class real numbers chapter 1. This is of 9th class, but other classes also 6th, 7th, 8th, 9th, 10th, all can understand this, and this is of their curriculum as well. So pay attention, you can also understand this is for your understanding as well. First question, a bit write any three rational numbers. A bit 3 write any three rational numbers. 1 by 3, 1, 2 by 5, minus 2 by 5. 1 by 3, 1 and minus 2 by 5. You can write many rational numbers. Then the B bit, A bit, this is, and the B bit, explain rational number in your words. A number which can be expressed or written in the form of P by Q, where P and Q are integers simply, and Q is not equal to 0. Q is not equal to 0. Simple, a number which can be expressed or written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Like example, we have written 1. 1 is a rational number. Can be expressed as 3 by 3, 4 by 4, minus 2 by 2. Okay, minus 1, it becomes minus 1. Anyway, this 1 can be written as this many ways. So this is a rational number. It can be expressed as P by Q form, where 3 by 3, 2 by 2, 4 by 4 are not integers and Q is not equal to, that is denominator is not equal to 0. You can take any, not just one. It can be, say, 1 by 2. 1 by 2 is equal to 50 by 100. These are all rational numbers. Second question is, give one example each to the following statements. The first statement is, a number which is rational but not an integer. A number which is rational but not an integer. Integers we know 0, 1, 2, 3, 4 and so on, and on this side minus 1, minus 2, minus 3. These are integers, and rational numbers can be anything. 2 by 3, minus 2 by 3 can be a rational number, but it's not an integer number. It's not an integer. All integers are rational numbers, but all rational numbers are not integers. So this is the first bit in the second question. A whole number which is not a natural number. Whole numbers we know, we have written before, we have seen before. Whole numbers include 0, 1, 0. It begins with 0. So 0 is a whole number, but it is not a natural number. Second bit, a whole number, example of a whole number which is not a natural number is 0. Because we know natural numbers begin from 1 and whole numbers include 0 as well. 0 is a whole number but not a natural number. Similarly, third, fourth, fifth bit, we have had classes where we have read or we have read about natural numbers, integers, whole numbers. In these statements, they mention these things. An integer which is not a whole number. You know, whole numbers start with 0. The prior numbers, these numbers include integers. Integers include minus numbers as well. Whole numbers are from 0. So minus numbers are integers but not whole numbers. Similarly, the fourth bit and fifth bit. Then the third question, find 5 rational numbers between 1 and 2. Rational numbers between 1 and 2. Third question, we know we have to do it in the form of a plus b divided by 2 in the mean method. So 1 plus 2 divided by 2. 1 plus 2 divided by 2 is equal to 3 by 2, that is equal to 1.5. That is equal to 1.5. You know, you can understand 1.5 is in between 1 and 2. 1.5 falls in between 1 and 2. Similarly, you can find more rational numbers with the mean methods when we have done in examples. Then the fourth question, insert three rational numbers between 3 by 5 and 2 by 3. Similar way you can do it. Fifth question, represent 8 by 5 and minus 8 by 5 on number line. These also examples we have done. So you can do this by referring the examples. Then the sixth question, express the following rational numbers in decimal form. That will do. Question is express the following rational numbers in the decimal form. We know we have done this, if you remember. Decimals we converted into rational numbers or fractions. Okay, 0.5 is equal to, we have learned that for the point you take a 1 in the denominator and as many numbers after decimal, that many zeros before, that many zeros on the right side of 1. So 5 by 10 is equal to 0.5 is equal to 5 by 10. If it is 0.352, becomes 52 divided by this 1 for the point and two numbers for two zeros for the two numbers beside the decimal. After the decimal, 52 by 100. Similarly, on this side, if we learn 5 by 10 is equal to 0. What we do here is 5 by 10 is equal to, take a decimal after 0, then only 5 here, because for 1 0 one number, that's all. Okay, then here 5 by 100 is equal to 0.05. For 1 take a decimal, for this 0 take another 0 and put this 5, it becomes 0.05. Similarly, I am repeating the same number for your understanding. 5 by 1000 is equal to 0.005. 0.5 is equal to 5 by 10. Here it is 242 divided by 1000. It becomes 0.242. Point for this 1 and 3 numbers after the decimal. It becomes 0.242. The second bit is 354 by 500. This we need to reduce it before, we need to simplify it before making it as a decimal. We need to simplify it. Both the numbers are divisible by 2 because both the numbers are even numbers. 2 1 is 2, here 1 is remainder, 2 sevens are 14, then 1 remains again, 2 sevens are 14. This we know, 252 times is 500, or 2 twos are 4, then 1 remainder, 2 fives are 10, then this 0 here, it becomes 250. 177 divided by 250. This we need to check whether these numbers are divisible by these two numbers. Both the numbers are not divisible by 2 and they are not even divisible by 3. 4, obviously, this being an odd number, it is not divisible by 4. And 5 also does not divided by 10. 5 divided by 10. 10 when we begin dividing 5 by 10, it is smaller than 10. So we take a point here, we take a decimal and we take a 0 here. The process of dividing, we know how to divide smaller numbers by bigger numbers. Then 10 fives are 50, 0 is the remainder. So the result is 0.5. 5 by 10 is equal to 1 by 2 actually. 5 1 the 5, 5 2 the 10. That is nothing but 1 by 2. 1 by 2 is equal to 0.5. 2 by 4 is also equal to 0.5. 3 by 6 is also equal to 0.5. Half of this. Half is equal to 0.5. That also you keep in mind. And 1 by 4 is equal to quarter. It is also called as 0.25. So when we got this, 5 by 10 is equal to 0.5. Similarly, 5 by 100 is equal to 0.05. When it is 0.5, here there is another 0. So we need to put that 0 here, 0 point. In short, if you divide 5 by 100, then you will still get this result. So when we know this, in short, we can use it in faster manner. 2 by 10 is equal to 0 0.2. 20 by 100 is also equal to 0 0.2. If it is 2 by 100, then it is 0. The second, now the second bit was 354 divided by 500. That is equal to 3.54 divided by 5. See children, listen carefully. 354 is nothing but 354 decimal after decimal 2 zeros, because there was nothing, so we kept it like 354. So 500 also similarly, 500 is equal to 500 dot 00 decimal, two decimals after two decimals. So when we divide this 354 by 10, we can simply move that decimal one place, 35.4. That becomes 35.4. 10, the decimal moves from here to here. The decimal comes, the result comes as 35.4. 4 divided by 100, simply it becomes 3.54. When we have seen here divided by 10, it became 35.4. So when this 0 goes, the decimal is here, 10, that is 10. The decimal comes to the next place on the left side. Another 0, 100 divided by 100, it becomes, the decimal comes two places for the two zeros. So that becomes 3.54. If it is 354 divided by 1000, it becomes 0.354. If you divide, you will get the same result. So if you understand it, then you can utilize it in a faster manner. 354 divided by 1000 is equal to 0.354. If the same 354 is divided by say 10,000, it becomes 0.0354. As many zeros the decimal goes, that many numbers left on the left. So we had this 354 by divided by 500. It was not 100, 200, 100 or 1000 in multiples of 10. So what we did, 3.54 by 5, when we removed two zeros and the decimal came two places on the left side. So we divided, or we are dividing 3.54 by 5. 5 is 3.54 is smaller than 5, so we took a decimal here, it became 35. 5 sevens are 35, we know. 35.4 minus 35 is 0.4. 0.4 is smaller than 5. We took a 0 here, it became 4. 4 is also smaller than 5. So we took another 0, putting a 0 here, it became 40. We know 5 8s are 40, no reminder. So the result is 0.708. So therefore 354 divided by 500 is equal to 0.708. So the other bits you do it on your own. Like we have seen before, 2 by 10 is equal to 0.2. Then do on your own, do it in your notebook and try to find out 1 by 10 is equal to 0.1. 1 by 5 is equal to 0.2. Like that, find out on your own. I know this, because I know this, I am writing it in simple. You people try to do it, many of them, like 2 by 100, I have told you it is 0.02. You do it in your notebook and find out for your own self, then you will become confident. If it is 20 by 100, again 1010, it goes and it becomes 2 by 10, then it becomes 1 by 5 is equal to 2 by 10 is equal to 0.2. Okay. Do for more numbers, 200 divided by 100 becomes nothing but 200 divided by 1000. Two zeros goes, it becomes 2 by 10 is equal to again 0.2. You do it and try for many numbers, then you will be confident how fractions are converted into decimals and how decimals can be converted into fractions. It is nothing but 5 by 10. No new number, This take this number 5 as whole number there and take 1 for the 1 for the decimal and this 0 comes here, it becomes 5 by 10. If it is 0.7, it is nothing but 7 by 10. If it is 0.55, it is 55 by 100. 55 by 100, because for this decimal we need to take 1 here. For two numbers we need to take two zeros. If it was only 0.5, that is nothing but 5 by 10. If it is 0.50, it is nothing but still it is 5 by 10. The 0 after the decimal here is nothing but it has no value. 0 after the decimal on the right side after a number has no value. So 5 by 10. So you people do it on your own, many more, then you will be confident about how to convert the fractions into decimals and decimals into fractions.